Hello everyone, myself Srivalli, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today we are going to discuss the pigeonhole principle, and also we are going to discuss about the problems on pigeonhole principle and applications. So these are the concepts that we are going to discuss today. So first, let us understand what is meant by pigeonhole principle. So pigeonhole principle, it is one of the fundamental concept in combinatorics and also in the mathematics. So let us see here what is the pigeonhole principle. So suppose a flock of 10 pigeons flies into a set of 9 pigeonholes. So let us suppose we have some boxes where we can call it as pigeonholes. So in that total how many boxes we have is 9 boxes. So let us suppose here we have 9 boxes. So out of this 9 boxes here, so we are going to put 10 pigeons. So we are going to say here, suppose this flock of 10 pigeon flies, they are going to take a build, or they are going to consider that it is a nest where they are going to get into 9 pigeonholes to roost. So because there are 10 pigeons but only 9 pigeonholes. So if you consider here only 9 pigeonholes, 9 boxes, but we have 10 pigeons, definitely one box will be contained. At least one box will contain more than 1 pigeons. So that is only our concept here. So only 9 pigeonholes, but out of this 9 pigeonholes must have at least 2 pigeons in it. So I'll repeat here. Suppose a flock of 10 pigeon flies into a set of 9 pigeonholes to roost, to build, because there are 10 pigeons here, but as we have only 9 pigeonhole boxes, definitely at least one box will contain 2 pigeons in it. So this illustrates this principle, we can call it as pigeonhole principle. So which states that if there are more pigeons than pigeonholes. So obviously here these are pigeonholes. These boxes we can consider it as pigeonholes, and the pigeons whichever are coming here, we have 10 pigeons, then definitely one pigeonhole box will contain at least 2 pigeons in it. So definitely here always pigeons are greater than pigeonholes. So in this particular case here, at least one pigeonhole will contain 2 pigeons in it. So of course this principle applies to not only these pigeons or pigeonholes, this principle will apply to the other objects also beside pigeons and pigeonholes. So this is the we can say the pictorial representation here, as we have the concept here itself, the pigeon or pigeonhole principle. So that's why we have given the diagrammatical representation here. So where you can understand here, if you observe here, we have total how many pigeonholes? Total we have 9, and out of this 9 here, so if you observe, the pigeons are 10. So how you can put this 10 pigeons into the 9 pigeonholes? So definitely one pigeon will contain at least 2 pigeons in it. So this is not only it is applicable for pigeons or pigeonholes, even for the other objects also. Let us suppose here I have 9 boxes. Let us suppose here I have 9 boxes, and in this 9 boxes I want to put 10 pens. 10 pens here I want to put it. I want to adjust this 10 pens out of this 9 boxes. So definitely here, if I keep pen 1, pen 2, pen 3, pen 4, pen 5, pen 6, pen 7, pen 8, pen 9, then obviously another pen will be left, and that pen will be adjusted in any of the boxes. Means at least one box will contain 2 pens in it. So this is like how we can understand the concept here with the help of pigeon and pigeonhole principle. Now we have the formal definition also. So besides this pigeonholes, this is a real-time example. So we have the formal definition for this pigeonhole principle. So that is, if k is a positive integer and k plus 1 or more objects are placed into k boxes. Let us suppose we have one k which is called as k positive integer, and we have k plus 1 or more objects which is nothing but, so k is a positive integer which is nothing but pigeonholes. So we have k plus 1 or more objects which are nothing but k boxes. They are placed into k boxes. So then there is at least one box containing two or more of the objects. So pigeonhole principle, we can also call this, the other name for the pigeonhole principle is Dirichlet-Dror principle. After the 19th century, so German mathematician name is Dirichlet. So he has given this pigeonhole principle. That's why here we are calling this pigeonhole principle is called as Dirichlet-Dror principle. So this Dirichlet is nothing but the name of the German mathematician. So who often use this principle in his work. So while he is implementing his work, so in that he has implemented this one. Now we have example also. Among any group of 367 people, there must be at least two with the same birthday, because there are only 366 possible birthdays. Why? Because if you observe here, so in a year we have 366 days. If you consider 366 days, so definitely at least 1 month they will have. So at least two people will have the same birthday in the 1 month. So not only in that, even the second example also, in any group of 27 English words. So altogether we have how many alphabets in English? 26. But in any group of 27 English words. So let us suppose if you are having one word which consists of 27 words. So at least one word will contain two times. So that is nothing but it will begin with the same letter, because there are only 26 letters in the English. So next, in the same way, we have generalized pigeonhole principle also. Now here, goal, number of holes will be given and we have to find out the number of pigeons. So how to solve the problems for generalized pigeonhole principle is, the goal that is you have to find out pigeons, number of pigeons, and in the question they will be given number of holes. So now definition, so for this generalized pigeonhole principle is, if n pigeons are assigned to m pigeonholes such that m is less than or equal to n, then at least one of the pigeonhole contains n minus 1 by m plus 1 pigeons. So here let us suppose we have pigeons n, and here pigeonholes are m. So we have n pigeons, we have m pigeonholes, such that always this m will be always less than or equal to n. So why? Because if you want to put this number of pigeons, so definitely pigeonholes will be less and you have to adjust these pigeons into this number of boxes. So definitely at least one box will contain more than one pigeons in it. So here the formula here you have to consider is n minus 1 by m plus 1. At least one of the pigeonhole contain here n minus 1 by m plus 1 pigeons. So this is the formula that we have to follow formally. So, and we have the problems also regarding this on this generalized pigeonhole principle. So let us see here. So the first question here is, prove that in any set of 29 persons. So here prove that in any set of 29 persons, at least 5 persons must have been born in the same day of the week. So here 29 persons, here our goal is to find out the number of pigeons, and also we have number of pigeonholes. But here the answer is also given here. If we observe the question here clearly, prove that in any set of 29 persons, at least 5 persons must have been born on the same day of the week. Means here, so you have to consider n is equal to, n is nothing but what here? N is nothing but here number of pigeons. So let us suppose here n is equal to 29, and in a week we'll have 7 days. So which is nothing but m is equal to 7. So now here we know that formula according to generalized pigeonhole principle. So according to generalized pigeonhole principle, we have the formula n minus 1 by m plus 1. So here what is n here? 29 minus 1 by 7. M is 7. So plus 1. So now if you observe here, 29 minus 1 is what? 28 by 7. So plus 1. So if you take 7 4s are 28, which is nothing but 5. So now here, what is the question here? Prove that in any set of 29 persons, at least 5 persons must have been born on the same day of the week. So now this is the answer here we have proved here. So this is like how you have to solve regarding generalized pigeonhole principle. And next we have another question also. So suppose that there are 26 students and 7 cars to transport them. Show that at least one car must have 4 or more passengers. So here, so from this question we can understand that here given n is equal to 26 and here m is equal to 7. So how I can say that here n value is 26 and m is only 7. Why can't m value is 26 or n is 7 is? So here we need to take the highest value as n. Why? Because this 7 is nothing but pigeonholes, just like a pigeonholes. So in this pigeonholes, in the 7 cars, you can able to adjust this person's 26 students as by considering this pigeonholes. So cars are pigeonholes and the students are pigeons. So you can adjust this 26 students in the 7 cars just by treating that students are pigeons and cars are pigeonholes. So to transport them. So if you want to transport the students here, many number of students, you can adjust in only 7 cars. So I can't adjust the 7 cars in 26 students. So this is the meaning will be completely changed here. So that's why here by taking the principle of pigeonhole principle, so you have to understand this n value is nothing but number of pigeons, just like number of students, and here cars are nothing but just like number of pigeonholes. Now, after considering this n and m value, according to the generalized pigeonhole principle, we have n minus 1 by m plus 1. Now here, what is n value here? 26. And we have minus 1, m is 7 plus 1. So 26 minus 1 here is 25 by 7. So plus 1. So here if you observe here, 7 3s are 21 and leftover you'll have here 21 means what? 4. So 4 means you'll get, so 7 5s are 35 which is nothing but 3.5. So 3.5 plus 1 which is nothing but 4.5. You can consider here it is 4. So which is nothing but you can have, must have 4 or more passengers. So you can consider 4 or otherwise you can consider 5 also. So it is not changing the meaning of the question here as we are going to get the answer 4 or more passengers. So this is the second question here. Next we have third question also. So the question here is, if 7 colors are used to paint 50 bicycles. So if 7 colors are used to paint 50 bicycles, show that at least 8 of them must have the same color. So now according to the question here, so you need to paint 50 bicycles by using 7 colors. So by using 7 colors means what here? You are going to adjust this 50 bicycles here, so to 7 colors, which is nothing but here n value is 50 bicycles and m value is equal to 7. And you have to show that 8 of them must have the same color. So the same thing here, the formula here is n minus 1 by m plus 1, which is nothing but n minus 1 is 50 minus 1 by 7 plus 1. So here if you observe here 50 minus 1 is 49, 49 by 7. So which is nothing but 47, 7 plus 1 is equal to 8 here. So here the answer is, show that at least 8 of them must have the same color. So as we got the answer here 8, so we have proved that here, so at least 8 of them are having the same color. So next, let us go to the next one. Show that if 30 dictionaries in a library contains total of 61327 pages, so then one of the dictionary must have 2045 pages. So here, so obviously n is equal to 61327 pages. So number of pages is here 61327 and the dictionaries are total how many we have? 30 dictionaries. Means show that if 30 dictionaries in a library contain a total of 61327 pages. So 30 dictionaries we have. So out of the total we have 61327 pages. Now we have to prove that at least then one of the dictionary must have at least 2045 pages. So now according to the formula here, so directly you have to substitute in the formula itself. This is the pigeonhole principle. So now here you will get 61327 minus 1 by 30 plus 1, which is nothing but 61326 by 30 plus 1. Then you will get the answer here. If you simplify it, you will get the answer 2045. So by using calci also you can simplify it here, the answers. So this is the final answer here. As we got the here answer 205, we can say that it is hence proved. So like these are the problems that you can understand how to solve regarding this generalized pigeonhole principle. So and also we have applications. So the applications of the pigeonhole principle are, the first one is number theory. Even in the number systems also we can use this pigeonhole principle. And in the number of outcomes like probability, how many ways are possible, how many outcomes are possible. So in this situation also, in the real life example, you can use this pigeonhole principle under probability. And even for the algorithms, we can use it. Even for analyzing the mathematics and even arithmetic numbers, we can use here. And in geometric, we will use. And even in economic or commercial uses also, you can use it. And for the finance, for the computer science related works, and also for computer programming also, we can able to use this pigeonhole principle indirectly. It's not directly, but you can use it indirectly also. You can understand that you are using indirectly the pigeonhole principle to the particular concepts. So what we have discussed today in this session is what is meant by pigeonhole principle, what is the formal definition of the pigeonhole principle, how you can understand it by understanding the pictorial representation. And also we have solved few problems regarding that, how to understand that generalized pigeonhole principle, what is the formula for generalized pigeonhole principle, and how to solve the problems under generalized pigeonhole principle. So by this, we'll end the session. Thank you.